Hi everyone. In the second tutorial today, I will talk about how we can draw different molecules using Avogadro. If you remember from the first tutorial where we discussed a little of all of these different tools, we will mostly be using the draw tool for drawing different molecules. And as you can see, the default element that's selected is carbon, and also the bond order is single, and you have double and triple there. So the adjust hydrogens option is checked, which means that I don't have to worry about drawing hydrogen or adding hydrogen atoms manually. They will be adjusted accordingly. So since carbon is selected and the draw tool is selected, if I just click here, I should get methane. And I clicked here. As you can see by rotating it, it indeed is methane. So yes, we have our first molecule here. Now, it looks pretty tiny, so if you want to zoom in or zoom out, if you're using a mouse, the best way to do it would be to scroll your using the scroll button on the mouse. Just scroll it up and down, and you'll be able to zoom in or zoom out. But if you're on your laptop and you want to look at it, so what you can do is you can just place two fingers on the touchpad and just move them like downward to zoom in, upward to zoom out. So you can just try playing with it, and you should be able to do it. So yeah, zooming in and zooming out shouldn't be a problem. And if you want to move the molecule around, like you can, here you're only able to zoom in and zoom out, and you see the molecule is here. If you want to take the molecule here, uh, press or hold down the command key on your keyboard and then hold the molecule with the mouse or your or using the touchpad with like one finger and then move it around. So as long as the command key is pressed, you can just move the molecule around wherever you want. And once the command key once you like stop holding down the command key, you can only zoom in or zoom out and rotate in a given fixed point in a position. Anyway, so we have methane here, and let's go back to the draw tool. If I hit axes, what it basically does is it shows the axes right at the molecule, and we don't want them. As you can see, we see the ball and stick model. That's because this is checked. If we hit cartoon, we don't really see anything because it's not a protein where you can have a cartoon. And if you see, if you hit dipole, you can actually see something. And we don't really have hydrogen bonds here. And in the label option, you can click the screwdriver like thing that you see there. And here I selected the label to be the atomic number. So if you want to name it by element symbol, you can see carbon, hydrogen, 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 hydrogen. And if you don't want any label, just hit none and you won't see anything. If you want symbol and number and group, carbon, since you have 4 different hydrogens, it's H1, H2, H3, and H4. Symbol and atom number, then it's this is the first atom, C1, then all the hydrogens are like second, third, fourth, and fifth atoms that came when you draw. So that's how it's labeled. You don't really have labeling by partial charge or by formal charge. So you have like labeling by partial charge here. If you want, you can do that, but I don't see how that could be very helpful. And if you want, use the full element name, and that's not super helpful either. And you cannot name it with the residue because it's not a protein. Again, you cannot use a residue number, or you can use a unique ID, like just again the order in which the elements appear. It's just starting from 0. And the custom data is just the element names, the symbols. So I usually go by atom number. It's just convenient for me, but you can label, you can choose whatever you want. And you can change the color here. So if you want to label it with, I don't know, turquoise, you can pick that. Wait, did I not select that? Okay, turquoise, and click OK. You need to hit OK. And it labels in turquoise, right? See? If you want to change it to, I don't know, green, you go for it, green. I think it's surrounded by red, but yeah. And you can change the font if you want. It's Helvetica bold 14. So if I want 18 and hit OK, I can do that. So if I want, I don't know if that would work. Looks like that isn't um working, right? No, that the changing font size is not working for some reason. But I guess if you want to change it to I don't know, Arial and maybe like 12, I still don't really see a change, but I guess it should be possible to do it. Text bond, like, okay, these are the bond labels. So if you see, it is labeling the bonds by the bond lengths. Bond numbers, so it labels the bonds, the first bond, second bond, third bond, and fourth bond. Between atoms 1 and 2, obviously you'll have the first bond, so that's how it's done. Bond order, then all of them will be 1 because they're all single bonds. Unique ID will just be 0, 1, 2, 3. It's just the order starting from 0, I guess. So I don't usually label the bonds. I don't really see how that can be super helpful, but if you want to label them, you can change the colors as how you like. So, and here you can see the atoms and the bonds. So the bond says that atom 1 is connected to atom 2, 1 is connected to 3, 1 is connected to 4, and 1 is connected to 5. So you can see there are no bonds between any of the hydrogen atoms. It's just that carbon is bonding with every other atom. So you can see the information here, and you can see how the atoms are labeled, the atom, the element symbol, and the number. So by clicking on this, you can actually you can explore and change the settings for each of the display types. So here the atom here the atom radius is this, but if I want to change the atom radius, I mean, I can make it as huge or as tiny as I want, but that's not what I want. So I'm just going to stick with what we have. That is covalent, and this van der Waals radius. So and then you have the bond radius too. So we don't want really thick bonds. So I'm not going to change anything to it. And if you have like, this is the opacity control. I just put it to maximum so you see things clearly. And again, you have the information color by element, which is the best thing to do, so that the standard colors are like carbon is in gray, hydrogen is in white, oxygen is in red, nitrogen is in blue, chloride is in green, or chlorine is in green. So it colors by element. If you want to color by distance, then that is it, or color by index, partial charge. So you can in color by residue, again, you have like different things, but that doesn't apply here because we don't have a protein nor an amino acid. So you can just leave it as color by element, which is pretty good. And you can try different settings here and see what happens to actually do it. You probably not really see much because you're not dealing with a protein. Yeah, but if you go for the stick representation, you will see that. And if I remove ball and stick, you just see sticks. So we don't want the stick. We will find the ball and stick. We don't really see a surface, but this is the van der Waals spheres. So like the huge spheres you can see there. And we don't have the wireframe for this either. So you can just play around with the different display types and see and pick what seems like the best fit. So we have methane here. It looks okay. So let's just go ahead and save it. So remember how we did it in the first tutorial, just type methane and it's an XYZ file, just save it. So if you want to clear it all up, use the selection tool and just move this around and you can select it. If you want to unselect it and you're on a laptop, just do the right click, which is like press with 2 fingers, and you should be able to unselect everything. Select everything, delete it. Let's go draw another molecule. Methane was pretty easy, right? So why don't we try something that has a double bond? Maybe ethane, ethylene, or ethene or ethylene. So let's try that. We have methane. Let me just connect it here. We have ethane. Now let me click on a single bond to turn it into a double bond. Now we have ethene, right? So here we go. this is how we can generate a structure with a double bond. Let's go ahead and save as ethene and save. So we have saved it, and we can select everything, delete it, and now try and drawing another molecule, something with a triple bond. Why do we have to just keep using carbon? Let's try something with nitrogen. So select nitrogen. You immediately see that you have ammonia, but then you get NH2, NH2. We don't want that. Not this. Just hit one more time, and you will see that what we have here is a triple bond. So we have an N2 molecule, right? So you can see the triple bond here, 1, 2, 3. So we have an N2 molecule, and yep, so let's save this. So this is how we can draw a triple bond molecule, N2. Now let's clear it up. Let's say we want to draw benzene. Okay, so when you go to other, of course, you have the periodic table here. But yeah, if you go to build, in this menu and go to insert, so instead of drawing some things, you can actually insert certain segments or molecules straight away. So if you click on fragment, so there are different things you see here that you can insert. If you go to amino acids, you can just insert the amino acid straight away. If you go to aromatics, you should be able to insert a lot of things just straight away. If you go here, benzene, like a lot of molecular structures are already preloaded, so you can just pick them and click insert and go back. Hang on, and but when you insert something, it's like it's all like fully selected. So hit the selection tool and right click to unselect everything. Or you can select everything and then just move it around and select it. Or yeah, let me just rotate it. As you can see, you have benzene. So there are a lot of molecules that are already there, which you can just insert. But if you want to draw benzene all by yourself, how do you do it? So let me select everything, delete, and now let's go to the drawing tool and pick carbon. So let's go here. We have methane. Now what I'm going to do is I'm going to click on carbon and drag until I have another carbon. Now click this, drag, click and drag, click and drag, click and drag, and click and connect. Drag and you connect it to the first carbon. As you can see, you have 6 carbons. You basically have something like a cyclohexane, but this does not look like a cyclohexane. It's neither in the chair nor the ring conformation. So we want benzene, so hit the alternate single bonds to change them into double bonds. So this is how a benzene molecule would look if we were to make it ourselves. And as you can see very clearly, it is not symmetric. It is not in the optimized structure. But we definitely did make a benzene molecule. So first, let's just go ahead and save it as benzene. Okay, now that we have saved it as benzene, if you want to add something to it, like maybe you want to have an amino benzene, right? And that will be just this. You just have to like hit something, and if you want to add maybe a chloride group or something to your benzene, so hit the carbon, click and drag. So you can replace a hydrogen with chloride. And if you want to actually add a methyl group, here click and drag and you have a methyl group. If you want to add an OH, click and drag. And if you want to add a fluorine, click and drag. If you want to add a sulfur, click and drag. So I'm pretty sure this molecule doesn't exist, but if you want to like draw something, you can definitely do it. So the whole point of this exercise is to show you that you can draw different types of molecules. You can either load them, like insert the preloaded molecules, or you can draw them, you can make them by yourself, and you can just move from one structure to the other with such ease. and you can just save it as. Don't hit save, because if you hit save, it will replace the benzene you had. So I usually go with save as. Benzene modified, it could mean anything. So now that we have created some sensible molecules and totally random molecule, let's just close it. And here in this window, you can see the different molecules that we created. If you double click, you see this, and you can see the bonds are missing because, well, it's not recognizing it as benzene because the bond lengths are not optimized, and the structure just looks crazy. So, as important as it is to learn how to draw molecules in Avogadro, it's equally or even more important to optimize the structures you draw so that we know what it is that we have drawn there, right? So in the next tutorial, I will talk about optimizing the structures. You can use, Avogadro lets you use different force fields to optimize the structures that you have. So the optimized geometry from Avogadro is not perfect because it uses force fields and not quantum mechanical calculations. However, they're definitely a great start to begin a quantum mechanical geometry optimization. If you provide the structure that is not optimized in Avogadro with the force fields, like the structure we have here for benzene, it will definitely take a much longer time for a quantum mechanical calculation or any other calculation to optimize this structure when as compared to optimizing the inserted benzene molecule, which was just perfect, or as compared to optimizing the benzene molecule that you used force fields in Avogadro to optimize. So optimizing molecules is very important, and I will discuss that in detail in the next section. Hope you enjoyed this tutorial. I'm looking forward to preparing the next tutorial and uploading it as soon as possible. Again, if you have any comments or questions or concerns, please feel free to comment them, and I will make sure to address all of those questions. If you also want me to make a tutorial about some other thing in Avogadro, please feel free to let me know, and I'll make sure to make a tutorial about that. And yeah, I'll try my best to explain it as well as possible. And I hope you enjoyed this tutorial.